The holiday season has come a few days early for meteorologists with the announcement of a new series of AI weather models now operational. Joining me now to talk about this is Daryl Kleist, Deputy Director of NOAA's Environmental Modeling Center. Thank you so much, Daryl, for joining me today.
Yeah, thank you for having me and for the opportunity to talk about this exciting development.
And let me start off with this. This all came from an initiative called Project Eagle. Can you tell me more about that and the motivation for developing these AI weather models?
Sure. So a few years ago, there were some pretty significant breakthroughs, in particular when some big tech companies, in particular Google DeepMind and NVIDIA, started demonstrating the ability for these new AI model technologies to produce something that looked like numerical weather prediction forecasts. So us and our peer center in Europe decided to start exploring this to see if we could replicate some of the results. Um, the prospects of being able to produce better forecasts with fewer computer resources and faster to provide evidence and to give heads up for people to have better lead time for high impact weather was really attractive to us. So the cost savings and the better forecasts basically motivated us to put this initiative together.
So people who don't really understand weather modeling, how does a machine learning AI model work differently than a traditional operational or ensemble model? How do they view the atmosphere a little different?
So they're fundamentally different in how they do their prediction. So a traditional model like we run today takes in observations to produce an estimate of the initial state and then basically tries to take equations as we understand them and very slowly and computationally expensive goes forward in time to produce a prediction. The AI models are very different. We've looked at historical data over the past decades and basically ask a machine learning model to learn patterns of behavior and do very simple sort of cheap forward calculations, sort of like matrix multiplication, very simple arithmetic. So it can do it much faster, and it's not bound by all the assumptions we have to make to do a physical model. So it does it fundamentally different based on AI technology instead of the brute force way we do with physical models.
So it's kind of looking at patterns based on this background knowledge of history rather than the equations that model the atmosphere like we always learn in atmospheric science school, like the QG equation and all of that. It's totally different in how it thinks.
Right, so those equations are built into the data that's used to train the model itself. So it's sort of implicit. It's not completely absent of those things, but it is not explicit when we do the forward simulation using the AI technology to go forward in time.
So what's now available? There's a whole suite of models. Can you explain the difference between the new AI GFS and the AI ensemble GEFS model?
Yeah, so it's very analogous to our current deterministic and ensemble models where we have a GFS, which does a single deterministic forecast of the weather, and the global ensemble forecast, which is many instances of that from sampling different initial conditions and different model representations to try to capture sort of model uncertainty and aspects of predictability. So it helps forecast the uncertainty. We've done the same thing with the AI models. We have a deterministic forecast, which is sort of our best guess, but we then do ways to perturb it to try to capture the uncertainty forward in time. So the ensemble represents sort of the uncertainty about a forecast, which is then tied to the deterministic forecast. So we get sort of a best guess, but also some estimate of the uncertainty in that forecast as we go forward in time.
And what about this new hybrid model? How does that work different from these purely AI new models that you've created?
So this one is a very exciting development for us. It's the first chance we've tried to combine prediction from an AI model to produce a product by combining it with a product from an ensemble traditional model. So we have 31 members in the global ensemble forecast system. We have 31 members from this new AI system, and we've created products using information from both. So it's effectively a 62 member ensemble to produce a forecast. So just by adding more members to better capture the uncertainty, but also because these models are fundamentally different, it's really moving the needle in capturing predictability, especially at longer lead times.
And I'm sure you've tested them for a little bit before they turn operational. Have you noticed that certain AI or your hybrid model has performed better than the traditional ensemble and operational GFS in certain weather setups like cold air spells? We've dealt with a lot of atmospheric river events and, of course, hurricanes over hurricane season.
So we've done extensive testing prior to the go live implementation this week, and we see from bulk statistics, it definitely gains lead time and predictive skill, particularly at the medium range, as much as 18 to 24 hours better forecast lead time. For particular events, we're still diving into it, but we have some anecdotal evidence that it is better at producing better forecasts of extratropical cyclone tracks and tropical cyclone tracks or atmospheric rivers with better lead time than traditional models. But there's also going to be cases we find where maybe the AI models are not perfect, so we still have a lot of work to do to best understand how to use this new technology in operational forecasting.
And that's why having a real forecaster on the other side looking at all this is so important. You know, people often look at their phones and the just generic weather app on their phone. And I tell you, the last few weeks, it's been predicting some wintry weather in Atlanta when we never had that in our forecast. So it's nice to know that there is a whole, workload and force of brainy scientists that are behind the development of these that are always looking at them. Have you compared it at all to the ECMWF AI model or Google's new DeepMind that was used during hurricane season by the National Hurricane Center?
So one thing, our AI GFS model is actually very similar to the Google DeepMind model that was used in demonstration mode with the Hurricane Center this year, although they tailored some of the technology specific to better tropical cyclone forecasts. But the underlying technology we're using in AI GFS is actually very similar. So we have done some comparative work with other AI models, including the AIFS, and they're all within the same ballpark in that they are all better than the physical models for many metrics at particular lead times. This is really just the first step, though, and we're really excited to be able to bring new innovation and even better predictive skill out of these AI models in the future.
And Daryl, do we have access to those immediately as private forecasters, or is that something that just the National Weather Service meteorologists have access to now?
The data is publicly available in real time on our usual data dissemination mechanisms, in particular our NOMADS website, for which people get a lot of our other traditional model data.
What about developments for the future? Are there plans to make mesoscale AI models or other tweaks to these as part of Project Eagle?
So in addition to improving the AI, GFS, and GEF suite with new variables, higher resolution, new technologies for representing the uncertainty in the ensemble mode, we do have prototypes of high resolution convective scale AI models, tropical cyclone specific AI models, and a whole suite of sort of application and phenomenological based sort of predictive tools. So we're very excited about how this is going to change the paradigm for operational forecasting in the future.
And let me close with this, Daryl. What are you most excited for personally, having been a crucial member of this development? What excites you about these new models?
This is a game-changing, once-in-a-career technology that we are just now scratching the surface of its potential. A lot of the things we have been struggling over the 2 decades of my career, there are completely new avenues of development and innovation we can now break through because of this new technology. So our ability to produce better forecasts, to give better lead time of severe weather, there are going to be major breakthroughs in the coming years, and we're very excited to bring this information to the public.
And major breakthroughs mean more lives can be saved and property can be protected in advance of those weather extremes. Daryl Kleist with NOAA's Environmental Modeling Center, thank you so much for joining me today.
Thank you for the time.